Hello everyone, today we're going to be working on fundamental problem 2.9, and this problem is asking us to determine the magnitude of the resultant force acting on a corbel and to determine the direction of the resulting force acting on the corbel measured counterclockwise from the x-axis. So what they gave us to work with is the amount of force going into each force. So force F of 1 is 900 pounds, F of 2 500 pounds, and F of 3 is 900 pounds. They also gave us an angle and that this is a 3 4 5 triangle. And from there, what we're going to do to start off this problem is we're going to first calculate the horizontal and vertical components of each vector. So let's start off with that. So the first thing is let's find the horizontal component of f of 1, which is this one right here. So we're going to write f of 1 of x because we're trying to find its horizontal component. We know that f of 1 is 900 pounds, so 900 pounds. And we're trying to find the horizontal component. So if we just zoom in, and if we were to draw a line to complete a triangle right here, that's a little too thick. Let's do like that. So if we were to imagine that that's a triangle. So what we're trying to do is we're trying to find the horizontal component of it. So we're trying to find this side, and this side is already given to us, which is the 900 pounds. And we also know this angle right here. So we know an angle and we know two sides. So what are the sides that we know? We know the side, the hypotenuse side, the hypotenuse side of it, and we also know the adjacent side to the angle that is given. So we know adjacent and we know hypotenuse. And yes, you guys are correct. If you guys are thinking we could use cosine, because cosine, remember, is adjacent over hypotenuse. And those are the two sides that either we're trying to look for or it's already given to us. So we're going to do 900 pounds times the cosine. Nope, we went too thin. Times the cosine of 30. And then we plug that into your calculator. And once again, make sure that your calculator is in degrees and not in radians. And that should give us 779.4 pounds. Now we're trying to find the direction of this 779.4 pounds. And if we look back at its original force, we could tell that this force is slightly leaning towards the left, which is why these 779.4 pounds are going to be going to the left. So we have now found the horizontal component of f of 1. So we're going to do the same thing for the other forces. So we have next f of 2 of x. Although f of 2 is a different case because, as you could tell, f of 2 is not leaning in any sort of way like f of 1 or f of 2. Like f of 1 or f of 3. F of 2 is completely straight. It's completely going down. There is no horizontal component to it, which is why f of 2 of x is simply going to be 0 because there's no horizontal component to it. So now we're going to move on to f of 3. F of 3 is slanted, so there is some horizontal component to it. So we're going to try to find its horizontal component. So now we have f of 3 of x is equal to, once again, f of 3 is also 900 pounds times. And for this one, we don't have an angle, but they did give us the slope, the 3 4 5. So once again, we're trying to find the horizontal component, which is this side, which is given to us as 3. And we could use cosine again. So that means we're going to use the hypotenuse, which is the 5. So we're going to have 900 pounds times 3 over 5. Plug that into your calculator, and that should give you 540 pounds. Now we're going to try to find the direction of that force, and as you could tell, this force is going to the right as compared to the other one that was going to the left, so this is 540 pounds going to the right. So this is very important to remember the direction that the force is acting on. So just like that, we finished all of our horizontal components, and now we're going to try to find our vertical components of each vector. So now we're going to find f of 1 of y. So once again, f of 1 is 900 pounds times, here we're not going to use cosine because we're not trying to find the horizontal, we're trying to find the vertical component. So now we're going to be using the opposite side and the hypotenuse side, which that is sine. Sine is opposite over hypotenuse, so we're going to use sine of 30 instead of cosine of 30 because we're trying to find the vertical component of it. Plug that into your calculator. Once again, your calculator should be in degrees and not radians, and that should give you 450 pounds. Just like how we did with the horizontal components, we're trying to figure out if this force is now going up or down. And as you could tell, this force is going downwards by the arrow, because going upwards, the arrow would be like this, and then with the arrow pointing slightly up, but here it is pointing down, so that is 450 pounds going down. So that's the vertical component of f of 1. Now we're going to try to find f of 2y, but f of 2 is already in a vertical component. We don't have to do anything to it because there was no horizontal component to it. So this one is just the 500 pounds. We don't have to do anything to it because it's already vertical. And that is going down. So now we just need f of 3 of y. We know that it's 900 pounds times, once again, here we don't have an angle, but we have the slope, the 345, and here we're trying to find the vertical component, so we're going to be using this side, which is the 4, and the hypotenuse. So it's going to be 900 times 4 over 5 times 4 over 5. We plug that into our calculator, and that should give us 720 pounds. And this force was also slightly going towards the bottom, as you could see. So all these forces were going down, which is why all of the signs of them are facing down. They're all going down. So now that we have our horizontal and vertical components, what we're going to do next is we're going to evaluate the net horizontal and net vertical components of these forces. So what we're going to do is we're going to try to find the sum or the net of all the horizontal forces. So what we're going to do is we're going to first set up. So we're going to assume that going right is positive. That's our annotation, that right is positive. So f of r of x is equal to, so we said that right is positive, so any force going to the left is going to be negative. Sorry, that's supposed to be an equal sign. So here we have 779.4 pounds going to the left. That means it's going to be a negative 779.4 pounds. And then f of 2 of x was just 0, so plus 0. And then our 540 pounds are going to the right. And as we mentioned earlier, right is positive, so we're just going to do plus 540 pounds. And if we add that all up, we get negative 239.4 pounds going to the right, but we want to work with positive numbers. We don't want to deal with negative numbers. So we're simply going to rewrite that as 239.4 pounds going to the left. So that's the sum of our horizontal components. So now we're going to try to find the sum of our vertical components. We're going to do the same thing. We're going to assume that up is positive. So f of r of y is equal to, we have 450 pounds going down, so that's negative 450 pounds, minus 500 pounds, minus 720 pounds. So if we sum those all up together, we get a total of negative 1,670 pounds up. But again, we don't want to deal with negative numbers, so we're going to do 1,670 pounds going down. So now that we have both of our net horizontal and net vertical components, what we're going to do is we're going to take these two numbers that we found and we're going to sketch them out to help us evaluate for our resultant force. So what we're going to do is we're going to draw out our x and y axis to help us like visualize this a bit better. So here for our horizontal or x-axis, we have 239.4 pounds going to the left. So that means 200, that's a little too thin. I don't think you guys could see that. Let's make it a bit thicker. 239 pounds going to the left. And for our vertical components or our y-axis, we have 1,670 pounds going down. So it's going to be going down this way. Now that we have that, our resultant force is a force that's going to be coming right here, which is what we're trying to find. We're trying to find its magnitude. So to find its magnitude, all we're going to do is we're going to do resultant force is equal to the square root of 200 and, let me rewrite that a little nicer, is equal to the square root of 239.4 squared plus the 1,670 squared. And that should give you the magnitude of your resultant force, and that should equal 1,687 pounds. So just like that, we already found our magnitude of our resultant force. This is the answer to the first part of the question. But as you guys remember, there is two parts to this question. So check, we did the first part. We found the magnitude, but now we have to find the direction of the resultant force, and we're going to try to find that counterclockwise. Counterclockwise means that we're going to be finding, so this is the x-axis right here. So we're going to try to find the direction going this way, counterclockwise to it, until we hit that resultant force. And if the problem would have asked you to find it clockwise, it would have been in this direction until we hit that resultant force. So based off this figure that we have here, we know that this is a full 180 degrees. So what we could do is we could simply just find this angle right here and sum that to 180, giving us the full direction of our resultant force. And to do that, we're going to use our little image right here. What we're going to do is we're going to draw a triangle out of this. So we're going to extend that out just a bit more. And basically, what we're going to do is, so this is the angle we're trying to find. We know this side, and we know that this side to the triangle is the same as this side right here. So we know that this side right here is the 239 pounds. And we know that this side right here is the 1,670 pounds. So we're trying to find this angle right here, and we know the opposite and adjacent side to it. So if you guys recall, tangent equals opposite over adjacent means, so that means that we could use tangent theta. We're going to call this angle here tangent theta to find that angle that we're missing. So what we're going to write is we're going to write tangent theta is equal to opposite over adjacent. So our opposite side was the 1,670 pounds over, and our adjacent side was the 239.4 pounds. Then we're going to get theta by itself, giving us theta is equal to the tangent inverse of 1,670 all over 239.4. We're going to plug that into our calculators. That should already be in degrees, and that should give us 81.9 degrees. So this angle right here is 81.9. But we're trying to find this full angle right here, and that full angle, we're going to call that phi. So we're trying to find phi. So to find phi, what we're going to do is we're going to take theta plus the 180. So what we're going to do is we're going to put phi, which is the overall angle that we're going to find, that we're trying to find, is equal to 180 plus the 81.9 that we found earlier, giving us 261.9 degrees, going counterclockwise from the positive x-axis. And just like that, we found the second part to our answer.